One of the most captivating cosmic phenomena is the possible supernova of Betelgeuse. Located in the renowned shoulder of the Orion group of stars, Betelgeuse is a crimson supergiant nearing the conclusion of its life cycle. Unexpectedly, in 2019, one of the most luminous stars in the heavens began to dim noticeably, being discernible even to the unaided eye. For a number of months, its brightness dwindled to an extent that numerous watchers questioned whether the star was perishing. Pointing their binoculars at the enormous star, researchers were amazed by proof of the significant dimming. Betelgeuse is thought to be on the verge of becoming a supernova, signaling the conclusion of its stellar existence. But when and how will this cosmic detonation transpire? Could it pose catastrophic impacts for our planet? The radiant scarlet star Betelgeuse can be found on the top right shoulder of Orion the Hunter. You might know it by its alternate title, Alpha Orionis. Despite the fact that it is the second brightest star in that constellation, following the supergiant Rigel, it continues to captivate scientists because of its shifting behavior and distinctive moniker. Alpha stars are generally the brightest within their star charts. Even though Rigel surpasses it in brightness, Betelgeuse draws attention due to its enormous size and reddish hue. Betelgeuse, also known as Alpha Orionis, is one of the most famous stars in the night sky, such as the 10th most brilliant and 7th most visible for much of North America, Canada, and Europe. The name it goes by is derived from Arabic and signifies the armpit of the giant, referencing its spot in the star grouping. Betelgeuse reduces by about 1 solar mass every 10,000 years, releasing substances in all directions uniformly and generating a nebula surrounding it. This nebula spans 30 astronomical units, or 30 times the distance between Earth and the Sun, and is 150 times more massive than the star itself. At its core, the hydrogen nuclei of Betelgeuse combine under enormous gravitational force, resulting in helium and emitting radiation and warmth in the moment. As the star's resources diminish, hydrogen begins to fuse into helium and carbon as substitutes. When helium runs out, neon combines with carbon to yield iron. Iron does not combine to generate power, causing the star to cave in under its own gravity and ultimately unleash a supernova, one of the universe's most forceful explosions. Depending on age and developmental phase, stars emit light in a variety of wavelengths, from the vivid blue of youthful stars to the red of elder ones. Based on Ptolemy, an ancient stargazer, Betelgeuse displayed a color he mysteriously referred to as ruddy. Nevertheless, early Chinese astronomers remarked that Betelgeuse looked yellow, implying that it might have been a yellow supergiant. Colossal stars rapidly burn through their hydrogen, resulting in a premature death, even if they have only existed for 10 million years. There is no doubt that Betelgeuse is nearing the end of its run. Despite the fact that our Sun still has more than 5 billion years, Betelgeuse, approaching its final moments, could someday erupt in a supernova. However, the precise schedule of this occurrence is unknown at this time. Betelgeuse experiences the cycles of brightening and fading, one happening every 5 years and persisting for around 100 days. It's assumed that the swelling and shrinking of its outer layers during these rhythms prompt alterations in its diameter and typical surface temperature. Widespread during its run, Betelgeuse's popularity grew due to its unpredictable conduct in 2019 and 2020, when its light dramatically diminished before recovering for a moment. A few scientists have hypothesized that this baffling activity could indicate the star is close to completing its transformation. Comprehensive analysis of Betelgeuse originates from the 1st century BC. Yet, the reason for its dimming is still an absolute mystery. Betelgeuse was spotted moving through the interstellar atmosphere at around 30 kilometers per second, after being tossed out of its birthplace in the Orion OB1 group, which houses Orion's belt of stars. The bow shock that follows extends well beyond for light years. Measuring the closeness of supergiant red stars like Betelgeuse is a well-known challenging task in astrophysics, as different factors hinder precise estimations of diameter. Furthermore, because it is a pulsating star. Betelgeuse's size varies over time. This quality, in addition to the darkening of its outer edge, results in an observed color shift in the glow and diminution as we look at it more closely from its core. Furthermore, the exterior material expelled by the star plays an important role in the production and absorption of light, influencing how we interpret its brilliance. Directly observing Betelgeuse from different perspectives is difficult due to its apparent size changes, which vary according to the observed wavelength. These measurements are subject to variations of up to 35% depending on the light's spectral percentage used. In July 2009, the European Southern Observatory released images captured with a very large telescope VLT interferometer at its ground-based observatory, revealing a massive gas plume extending up to 30 astronomical units from the star's surface, one of several large-scale expulsions observed in Betelgeuse. This outflow corresponded to the angle of separation between Neptune and the Sun. At least 6 such events have been identified around Betelgeuse. These scenarios might reveal clues to the question of mass ejection in the final stages of massive stars, which may be central to their annihilation. The complex processes within Betelgeuse's upper layers remain puzzling, as does the exact method by which red supergiants cast off their matter. These stars are fundamental to the circulation of elements that make up galaxies. Thanks to improvements in interferometry, astronomers are approaching answers to these mysteries. In 2019, researchers using the Hubble Space Telescope and other observatories discovered that Betelgeuse had lost a significant portion of its outer shell, triggering a substantial surface mass expulsion (SME). Unlike the Sun's mass ejections, Betelgeuse's events were thousands of times more extreme, with emerging material 400 billion times the mass of a typical solar eruption. This accounted for Betelgeuse's severe drop in luminosity in October 2019. By mid-February 2020, its brightness had nearly tripled, shifting from a magnitude of 0.5 to 1.7. On February 17, 2020, Betelgeuse's brightness had largely stabilized for more than a week. By February 24, 2020, it appeared that the dimming had stopped entirely. However, the recent reductions in visible light were not connected to a probable core collapse, as no significant changes in infrared radiation were recorded. Feel free to share your thoughts in the comments section. If you enjoyed this content, click the subscribe button and the thumbs up icon so you won't miss more updates. When Betelgeuse eventually explodes as a supernova, it will be among the most dramatic cosmic events ever documented. Even at a distance of 640 light-years, the explosion will be radiant enough to outshine the entire moon and be visible in daylight for weeks or even months. According to experts, the supernova will release more energy in a matter of seconds than our sun will emit throughout its entire 10 billion-year lifespan. The explosion's illumination will speed through space and eventually reach Earth as a brilliant pinpoint of light, unlike anything witnessed before. Rest assured, we are entirely safe. Although supernova at this distance might sound threatening, Betelgeuse remains far enough that the detonation will not harm Earth's living things or biosphere. What it will do is provide an exceptional scientific opportunity. In recent years, Betelgeuse has returned to typical brightness levels, but irregular patterns of dimming persist and remain under close supervision. Scientists are using instruments like the James Webb Space Telescope, the Hubble Space Telescope, and ground-based interferometers such as the VLT and ALMA to observe surface light patterns, fluctuations in convective activity, and constant mass expulsions that reflect the star's instability. One well-supported theory is that Betelgeuse's significant fading was caused by a vast cloud of starborn dust created during one such eruption, momentarily veiling the star's light from our perspective. Understanding the mechanisms behind Betelgeuse could help astronomers decode the life phases of massive stars, particularly those nearing a supernova. Such insights could aid in forecasting similar phenomena in other galaxies, explaining how chemical elements enrich the cosmos and detailing the creation and scattering of elements like iron and gold throughout space. Betelgeuse is effectively a ticking cosmic timepiece, winding down slowly. It may explode tomorrow, next year, or in 100,000 years. However, when it does, it will present a galactic spectacle and a wealth of scientific data unmatched in modern times.